Okay, I think I will start my presentation. Hopefully you can hear and see me, and you can also see my presentation as well. If not, please say something. Hello everyone, my name is Mete Atamel. I am a developer advocate at Google. I'm actually based in London, and right now it's right after midnight in London. So if I sound a little bit sleepy, it's because it's usually like past my bedtime. But I'm happy to be presenting here tonight. And today I will be talking to you about event-driven serverless architectures with Knative and Cloud Run. But before I start my talk, I tweet about this cloud native, K-native kind of topics on my Twitter. I also maintain a blog at atamel.dev where I talk about Knative quite a lot. And the presentation itself, it's already on speaker deck, so feel free to get it from there as well. In terms of questions, I think we have plenty of time. This talk is usually 40 minutes or so, but we have 1 hour, so feel free to stop me and ask questions. I will also check the Slack as we go along and see if there are any questions there, but feel free to also, if you can, like, stop me and ask questions live as well. That's fine with me as well. All right, so let's get started. Well, since we're talking about Knative and Cloud Run, which is a serverless way of running containers, let's first do a little definition of serverless and containers, and then we'll get into Knative. What I'm going to do is there are two parts of Knative, Knative serving and Knative eventing. The main points of the talk is Knative eventing. But before we can get to Knative eventing, we need to understand Knative itself a little bit. So I'm going to be talking about Knative at the high level, and I'm going to be talking about Knative serving a little bit and show you a couple of demos of Knative serving so that you understand what a Knative service is. And then we'll get into Knative eventing, and then I will show you what Knative eventing provides in terms of event-driven architectures. Now, in terms of serverless, when we think about serverless, there's two ways of thinking about it. First is the operational model. How do you actually run code in a serverless way? And in the operational model, when we say serverless, we usually mean no infrastructure management, meaning there's no machines or servers to manage for our code to run. We usually take security granted, at least the base level security, so we don't have to worry about blocking ports or worrying about whether we have the latest operating system patches, stuff like that. And then the best thing for serverless for me in terms of operational model is it's the payment model, right? In serverless, you usually only pay for what you use. Usually these serverless services, they scale up as people use them, but if no one uses them, they scale down. And when they don't run, you don't pay anything, which is great. Now, on the other hand, in terms of the programming model, when we are talking about serverless, we mean services. So it's service-based that are triggered by certain events. So they're event-driven. Either this event could be an HTTP call or a pops-up message or a storage kind of event. But either way, there's some event triggers your code. And usually your code is stateless. And the reason for this is that these serverless frameworks, they're usually elastic. They scale up your service or container and they scale it down. And to be able to do that in a quick way, it's much better if the state is external. So state is usually not in your code, but it's externalized. That way you can scale up and down pretty quickly and then get the state as you need it. So that's roughly what we mean by serverless nowadays. On the other hand, we have these other things called containers. And what containers provide for us is basically a context that we can replicate anywhere we want. This context, it's what a container image is. It basically includes your application, it includes your application's dependencies, and it includes the environment that your application needs, like the port or any other kind of environment that you need. And you put that in a Docker file, so you define a container image, and then when you run your container, you can rely on this context. So whether your container runs locally in your machine or whether it runs, in the cloud, it has the exact same the context, and that's a great thing because with that context, consistent context, you get reliability for your code. And the other great thing about containers is that you can use pretty much any language you want, any library you want, and there's a rich ecosystem around containers. For example, there's Kubernetes to run containers. There's Istio to manage the traffic to your containers. There's Knative that we'll talk about to run containers in a serverless way, right? So when you think about it, when you start a project, you had to make a choice at the beginning of your project. You either go with serverless, and with serverless, you get a lot of velocity because serverless abstracts a lot of things for you. And with that, you can focus on your code, and with that, you can iterate fast. So that's what I mean by velocity. But then there are certain times where serverless doesn't work for you. Maybe you want to use a certain language, and that language is not supported in the serverless runtime that you are trying to run on. Or maybe there's a use case that you want to support, but serverless framework doesn't allow you to do that. For example, there's usually some kind of timeouts in serverless frameworks. So if you need to run something long running, maybe you cannot do it in a serverless way. So what do you do when that happens? You usually fall back to containers because you don't want to run your code on physical machines or virtual machines anymore. So the next best thing is put it in a container and try to run it in a container. You probably use something like Kubernetes to manage a container. So you get the flexibility with the containers, but then you lose the benefits of serverless, and that's a shame because the serverless it gives a lot of things, and it's a shame that you have to lose that with containers. But thankfully, the projects like Knative and Cloud Run, they try to solve this problem. So they try to give you tools so that you don't have to make this choice between serverless and containers. Knative, it's an open source project. It was started by Google, but now a number of companies like Red Hat, IBM, and others, they're contributing to Knative. And the whole premise of Knative is to turn Kubernetes into a serverless framework. So it provides a number of components that you install on top of Kubernetes, and it makes it so that you can deploy containers in a serverless way on top of Kubernetes. And we'll look at what this means as we go along. Now, Knative is open source. It runs everywhere you can run Kubernetes, which means it can run on-prem, it can run on Google Cloud, AWS, Azure, anywhere you can run Kubernetes, basically. But if you are running in Google Cloud, there's two versions of Knative called Cloud Run and Cloud Run on Anthos. These are managed versions of Knative. Cloud Run is the fully managed version, and the Cloud Run on Anthos is the version that runs on Google Kubernetes Engine. It's the one where people want to stay in Kubernetes ecosystem, but they want to run on Google Cloud, they would choose Cloud Run on Anthos. Today's talk is mostly about Knative open source, but everything I show you about Knative, they also work with Cloud Run in an easier way, because in Cloud Run you don't have to worry about clusters and managing things about the cluster. So the point I want to make here is basically Knative ecosystem it's a spectrum, right? You have the open source version that you can run anywhere, but you have the managed versions as well. So they are more like services. And it's up to you basically where you want to be in the spectrum. The Knative stack looks like this. At the bottom layer, you have Kubernetes. On top, you need to install a gateway. Because Knative, it doesn't try to solve networking problems. It doesn't try to figure out how to get traffic to your container from the outside world to your container. instead it relies on a gateway like Istio or other gateways that you can install. Typically, I've seen people use Istio because that's the most fully fledged gateway that works pretty well with Kubernetes, but you have choice here. Once you have Kubernetes and the gateway installed, you install Knative components, the Knative serving and Knative eventing. You don't have to install both. If you need just Knative serving, you can just use that. But if you want Knative eventing, serving is the prerequisite. So you need to install serving and then eventing if you want to use eventing. We'll look at both. So I'll look at serving briefly, and then we'll get into eventing after that, which is the main point of the talk. And then, as I mentioned, on top of Knative itself, there's other products that are being built like Cloud Run, but other cloud providers, they also have other products built on top of Knative. So if you are running in other clouds, make sure you check out what Knative implementations they have. You probably want to use the product that's being built on top of Knative, because Knative itself, it's kind of like a platform, but on top of that, you typically need a product to be able to use Knative in an easier way. And on Google Cloud, this is Cloud Run, but as I mentioned, in other clouds, there's other implementations of Knative. All right, so let's look at Knative serving first. One second. So Knative serving, what is it? In a nutshell, Knative serving allows you to deploy containers in a serverless way. And what I mean by serverless is that, in Knative serving, you say, here's my container, here's the configuration of my container, and then just deploy this container. And then Knative serving does all the underlying work for the container to work as a service. So what it does is that it creates a pod for the container, then it configures the traffic, so it configures the Istio traffic to get to the container. Then once the container is up and running and the outside traffic can get to the container, it sets up automatic scaling. So by default, your container runs on a single pod, but it can scale up to N, and it will scale down to 0 if no one uses it after 60 seconds. That's the default case. So it sets up automatic scaling. Every time you want to make a change to your container, you can change the configuration and you can deploy again. And with that, you get a new revision. So there's revision management. You can have multiple revisions of your Knative service. And then once you have multiple revisions, you can do traffic splitting among those revisions, right? So this is what Knative serving is in a nutshell. It basically allows you to deploy a container, get traffic to it, get it also auto-scaled, and get a basic configuration, revision management, and traffic splitting. Yes. So the Knative serving building blocks, I already kind of covered these, but just to recap, at the top layer, you have a Knative service. Keep in mind that this is not Kubernetes service. In Kubernetes, there's also the notion of services, but Kubernetes services are kind of lower level than Knative services. Knative service is it's a higher level API. So you have your Knative service, you have a configuration of the service where you point to your container image, your environment variables, things like that. You deploy your service and configuration, and you get a revision, a snapshot of that service and configuration. And this revision will be pointed from a route. So route defines how the traffic goes to which revision. So by default, every time you deploy a revision, it gets all the traffic. Now, every time you change anything about the configuration, you deploy again and you get a new revision, and the route will be updated to that revision, right? This is the default case. But of course, once you have multiple revisions, you can change the route yourself here, and you can set rules yourself. So you can say things like, for example, revision 1 gets 50% of the traffic, and revision 2 gets the other 50%. Okay, so this is Knative serving. So let's just look at some examples of Knative serving, and then we'll get into Knative eventing after that. First of all, I should mention that I have this Knative tutorial on GitHub. I will share the link of this tutorial at the end of the presentation as well. And in this tutorial, I show you how to set Knative, so how to install Knative. And I have a setup script to set up Knative on Google Kubernetes Engine. I actually tested this tutorial with the latest version of Knative as of today, which is 0.18. And once you have Knative installed, you can check that it works by checking the pods of Knative. So let's actually do that. And this is my Google Cloud console. And I created a Kubernetes engine on Google Cloud. I installed Istio on top of the Kubernetes engine already, because Istio, a gateway, is also a prerequisite for Knative. Then I installed Knative latest version on top of that, using my tutorial scripts. So I have this set up already. Let's just make sure that my pods are running. So here I am in my console. So what I'm going to do is I'll just say kubectl get pods, and then look at Knative serving namespace. This is where Knative serving gets installed. I just want to make sure the pods there are running, and you can see that the pods are running. So as you can see, Knative is just another application running on top of Kubernetes. And if we do Knative Eventing, we see the Knative Eventing pods are running as well, which is great. Okay, so now Knative is installed, and I want to deploy my container on Knative. What do I need to do? Now, first of all, I need to create my code. In this case, I have a hello world example. So let's just quickly take a look at the code. It's very simple. You can see that there's a Docker file because it's a container, and we're going to deploy a container. You can also see that this is, by the way, this is C#, but I also have a Python version. You can use anything you want, really, any language you want, as long as it's a container. In this code, what I'm doing is that I am looking at a port environment variable, and if it's there, I will use that. If not, then I will bind to port 8080. This is a requirement of Knative. You need to bind 0000, and then you need to bind to port environment variable if it exists. Usually this points to 8080, but if not, it can also point to other things. So that's why you need to read it and bind to that. So that's one of the requirements of Knative. So that's what I'm doing here. Then in startup, where I actually handle the requests, what I'm doing here is that, what I'm doing here is that I am handling a GET request. I am reading an environment variable called target. And if I see that target, I will just reply back saying, hello, target. Did someone have a question? No. Okay, I will continue. So basically in here, I get a GET request, and then I check the target environment variable, and then I'll just say, hello, that target environment variable. So hello, v1, v2. So this is my code. It's something very simple. Then to define a Knative service, I define a service.yaml file. Now in this service.yaml file, first, what you will realize is that I'm using the Knative API. So this is the Knative API. The kind is a service. This is the name of my service, hello world. This is the namespace. So this is the namespace that this service will be installed. In this case, the default namespace. Then this is the configuration of my Knative service. The configuration has an image so this is the image that we're deploying, hello world version 1. And then the value, I'm also passing in an environment variable called target, and the value is v1. So we're going to read this target, and we're going to print it out, right? So this is the definition of a Knative service, and that's how you deploy containers with Knative. So let's actually deploy this and see how it works. Before I deploy it, I'm going to watch some things. So I'm watching Kubernetes pods, Knative service, configuration, revision, and route. So right now, there's nothing installed yet, so we don't have anything here. And then here, let me make this a little bit smaller. I want to deploy the first version of the service. So we are deploying the first version of our service. As soon as we do this, you can see that Knative realized that there's a new service that's been deployed. So it created the service. It created a configuration for the service. It created a revision of the service, and this revision is generation 1, so it's the first revision. It created the route for my service, and the route points to this URL. I set up zip.io, which is a dummy domain service for my service, so I don't have to set up a real domain, but that's what route is pointing to. And then it also created the pod for my service. So the pod is also, as you can see, it's running. So all the things that we talked about, the Knative service, configuration, route, revision, they're all created, and the pod is also created. And if I do a curl to this URL, you'll see that it says hello v1. So the service, so the container is already getting traffic from the outside world. If you ever did any kind of Kubernetes deployment, and if you ever use Istio, you will realize that this is much easier than using Kubernetes and Istio directly. Normally, if you want to use Kubernetes and Istio yourself, you have to create the pods yourself, you have to create a deployment. Then in Istio, you have to create a gateway to enable HTTP and port 80. Then from the gateway, you need to create a virtual service to connect the virtual service to your Kubernetes service. So there's a lot of things that you need to set up to get things working. Whereas in Knative, you create a higher level Knative service and you point to your container, and then the rest is done for you, basically. Now, if I want to change anything about my service, so let's look at service v2. In here, what I'm doing is that I'm changing my environment variable, and I'm changing the value of target from version 1 to version 2. So I'm doing a configuration change. So we can do that change and apply that change and see what happens. And then in service v3, we are changing the image. So this image, now instead of pointing to version 1 or hello world, it's pointing to version 3 or hello world. So we are doing code change here. And the code, basically what it does in version 3 is instead of saying hello, it will say bye, right? So that's the change that I'm doing. So let's see how we can apply these changes. So let's just apply service v2 first. So we are doing a configuration change. One thing you'll realize is that, first of all, this pod is terminating. This is version 1. It's terminating because we haven't used version 1 for 60 seconds. So it's scaling down to 0. So as I mentioned, Knative has auto-scaling by default. So it's scaling down to 0. But at the same time, we created a second revision of our service. So this is the second revision, and you can see it's generation 2. And then we have pods running for the second revision, right? Now, if I do a curl to the URL, you'll see that it says hello v2. So we did a configuration change and we applied it, and it's already up and running. Now, if I want to do a code change, I will change the container image. We point to version 3 or service where it points to the new container. And again, you will see that a new revision has been created. This is generation 3. And then the pod has also been created. So if we do curl again, now it says by v3, right? So we did a code change. Of course, in the real world, you don't change code like this. What you need to do is you need to do your code change. Then you need to deploy your service in a separate URL, and then test out that service, make sure that the new version works, and then gradually send traffic to it. So maybe at some point you want to do 50% of traffic splitting between the new version and the older version. And then once you're happy with the new version, you would send all the traffic to it, right? So you'll gradually send traffic to the new version. Knative makes this really easy, actually. So first of all, in Knative, there's something called named revisions. One thing that you'll realize here is that we have 3 revisions, and they all have random names. It's hello world dash some random number. You can actually give these proper names, and by giving them proper revision names, you can split traffic in an easier way. So let's see how we do that. So in the service v1 pinned, I go back to version 1 of my service. So I'm going back to version 1, but I am also giving my service revision a name. I call it hello world dash v1. This is the name of my revision that I am naming myself. And I'm also specifying a traffic rule. In this traffic rule, I'm saying that 100% of the traffic should go to this revision, which is the revision that I just defined here. And anything else I deploy after this, it should not get any traffic, right? So that's what I'm defining here. So let's apply this and see what happens. So now we are going back to revision 1. But then you'll see that the difference in this case is that this revision has a proper name now, hello world v1, right? It has a proper name. We are creating the pod for it as well. And then if we do a curl back to the URL, we are back to version 1. So all we did is we deployed version 1, but with a proper name. Now, let's say I have a new version called version 4. In this version 4, I just changed my environment variable from version 1 to version 4. I also give this revision name a proper name, hello world-version 4. But then in the traffic rules, I haven't changed anything. So hello world-v1 still gets all the traffic, and everything else, which is version 1, version 4 in this case, is not getting any traffic still, right? So if you deploy this, what you will see is that service v4, what you will see is that we created version 4. So this is the newest version. There's also pods running for version 4. So everything is deployed. But if I do a curl again, we are still at version 1. That hasn't changed. But version 4 is deployed, because if I go to this URL and add latest dash at the beginning, I can see that version 4 is running, right? So we did a silent deploy of version 4. And then we can go to this URL and test this URL and make sure that everything works. But then the main URL is still pointing to version 1, right? Now, at some point, you'll want to send traffic to version 4. And to do that, you just go to your service definition. And then what you say is that you just update your traffic rules. And you say, 50% of the time, I want version 1 to get traffic. And the other 50%, I want version 4 to get traffic, right? So we are doing traffic splitting. And then if we apply this latest change, service v1, v4 split, now nothing new is being created here because we already have version 1 and version 4. We already have the pods of version 1 and version 4. But the only thing that's changed in this case is the route. The route is updated to point to version 1 and version 4 50%. So if you do a curl again, you see that it says hello v4. Another curl says hello v1. So roughly 50% of the time we'll be going between version 1 and version 4. And then at some point, if you are done with the service, you can just say hello kubectl delete Kubernetes service, Knative service, and hello world. And then this will delete the service, and this will get rid of all the pods, all the revisions and everything, and we'll be back to where we were at the beginning of the talk, right? So the pods are terminating as well, and that's it. All right, so that's Knative serving. So hopefully this clarified what Knative is and what Knative serving enables you to do. Now, the second part of Knative is Knative Eventing. And Knative Eventing, it's basically, it provides you building blocks to connect different event sources to different event consumers using some kind of event flow in the middle, right? So it gives you building blocks for that. These event sources, they can be many different things, and we'll talk about that. These event consumers, they are either Knative services or they could be also Kubernetes services as well. These event types, again, they depend on what the event sources are, but they eventually get converted into something called cloud events, and we'll talk about that. And the delivery methods, there's basically a few different ways of getting events to your consumers, and we'll go through those as well. So the terminology of Knative Eventing is basically, you need to know about cloud events, you need to know about event sources, there's brokers and triggers, that sets up how the events are delivered. There's services, these are the consumers of the events. And finally, there's channels and subscriptions. As you've seen, channels and subscriptions, I didn't highlight them because they are typically not things that you should worry about. They're usually set once, or they're created under the covers, and you don't usually set them yourself. So usually you need to worry about event sources, brokers, triggers, and services. But in some cases, you might need to think about channels and subscriptions as well. So that's why I'm going to mention them as well. But typically, you don't need to worry about them too much. So let's go through these in this order. And then my plan is to go through them, explain them what they are, and then talk about delivery methods. And then in the end, I want to show you an event-driven demo where we'll bring everything together. And I will show you somewhat of a real-world application where I use all these constructs to build an event-driven application. So first of all, the events going through Knative, they're cloud events. Cloud event, it's an open source eventing definition from CNCF. So you can go to cloudevents.io to check it out. In Knative, well, first of all, cloud event format it's very simple. A cloud event has basically a small metadata part, where you have the type of the event, the source of the event, the ID timestamp. So typical things you expect from an event. That's what Cloud Event has. And then the data field of Cloud Event has the actual payload. For example, in this case, you can see that we are reading different kinds of events into our cluster, but then they get converted into Cloud Events, and data field, in this case, the GitHub event will be in the data field. So once the event gets to the broker, which is the entry point to Knative, the event will be Cloud Event. And that's nice because it's a common format that we can rely on. By the way, Cloud Events, they also have their SDKs. So you can use these SDKs to read the actual Cloud Events, but it's also very easy to construct a Cloud Event yourself. So it's just an HTTP call with some headers you can set yourself, and you can do it that way as well. So that's the format of the event. What kind of events you can read into your cluster? Well, first of all, you can produce events yourself within the cluster. So as I mentioned, these Cloud Events, you can construct them yourself either using the SDK or just using plain HTTP. So you can have a pod that creates these events and sends these events to the broker. So that's one way of creating events. But then the other way, and the more kind of common way of getting events into your cluster, is using event sources. And these event sources, they're basically things that pull external events into your cluster, and then they convert these external events into Cloud Events for you. The vendors, such as Google Cloud, AWS, they have these event sources that you install into your cluster. And then with these event sources, you can read external events, such as AWS events or Google Cloud events. This is not the full list, by the way. This is just a sample of what the events are. You can go to this link and you can see all of the events. You can also write your own event sources. So if you have something custom that you want to read into your cluster, you can write your own event source and pass it into your cluster. Okay, so once you have your events in the cluster, you need to send them to your services. But before you do that, you need to send them to the namespace of the services. And the entry point to the namespace is called broker. Broker, it gets injected into the namespace. So you label your namespace with this Knative namespace injected label. And once you do that, broker gets injected into your namespace, and it will be waiting to receive messages. So event sources will basically pass the messages to the broker. And broker also has a default URL that's accessible within the cluster. So if you have something in the cluster that needs to send messages, it can use this URL and get to the broker to send messages, right? So the events get to your namespace through the broker. Then from the broker, you want to send them to Kubernetes or Knative services. And to do that, you need to create a trigger. A trigger, it's the connection between the broker and the service. You typically create a filter because you don't want every service to receive every kind of message. So what you do is you create a free filter and you tell what type of messages you want to receive. So in this case, we are saying that we want to filter messages with type Google Cloud Storage Object Finalized. So these are Google Cloud Storage events. So we are basically looking at the Cloud event, and we are looking at the type field, and we are making sure that the type field is matching this one, right? But type is not the only thing that you can filter. You can filter with all the Cloud event headers, basically. So once you filter this event, you will send it to a subscriber, and that subscriber, it's a Knative service called filter. So we are sending Cloud Storage events to filter service, basically. That's what this trigger does. And then the service, it's either a Knative service. So in trigger, you mention a subscriber, and this is either a Knative service. Typically, it's a Knative service, but it can be pure Kubernetes service as well. So if you change the API revision from Knative API to Kubernetes API, it can be a Kubernetes service as well. And then I mentioned this before, but channels, you don't necessarily need to worry about them all the time, but channels, they define how the messages are persisted in your system. By default, you have an in-memory channel, meaning everything is in memory. This is good for demos, but then if your broker goes down or if your services goes down, there's nothing persisted. So what you typically do in production is that you create a more persistent channel, like Kafka channel or PubSub channel, and then you set this channel to the broker so that broker has an underlying persistence layer in case something goes wrong, right? And then finally, there's subscriptions. So for example, here, when we say subscriber in trigger, this under the covers creates a subscription, and that subscription sends the messages to the actual service. So that's what subscription is really. And subscription also makes a connection between the channel and the actual subscriber. But this happens under the covers. You don't typically create subscriptions yourself. You just specify your service and it gets created for you. But I just want to mention it in case you want to, in case you see them and you're wondering what they are. All right, so these are the main building blocks for Knative Eventing. Now I want to talk about the different ways you can send messages within Knative, and then we'll look at an example where we use some of these constructs. There's a few different ways in Knative on how you can send messages. One is what I call simple delivery. The other one is complex delivery, and the other one is broker and trigger delivery. Typically, broker and trigger is the one that you should care about because it does everything that others do as well. But there are certain use cases where the other two might be useful. So that's why I'm mentioning them here. But I'm going to be showing you broker trigger delivery later in my demo. But that's the one that you should really care about. So in simple delivery, you connect an event source to a service directly with nothing in the middle. I call it simple because it's simple. There's source and service and nothing else. But it's also very limited. In this case, you can have only one source and one service. So you cannot do fan out. And then there's no persistence either, right? So if source goes down or if the service goes down, the message gets lost. There's no channel or anything like that in the middle to keep track of the messages. But for certain use cases, this might be all you need. For example, in Knative, there's a source called ping source. And this ping source basically just sends a message to the sync, in this case, a service, using a schedule, right? In that case, you don't really care about if a message is lost once in a while. So maybe this is useful. And actually, let me show you the code for this. For example, if you want to do a direct connection from sync to source, I have this in my tutorial. So if you look at eventing and under simple, you can see that I have a Knative service. And this Knative service it's an event display. So it just displays the received cloud events. And the source, it's a ping source. It's kind of like a cron that pings the sync that you define. The schedule is like this, which is a cron schedule. I think it means every minute. And then you can also set up a JSON data. So what ping source does is that every minute it will send a cloud event with this message in the body as the JSON data. And the sync is a Knative service, right? So this is a simple delivery model, ping source to Knative service, right? And in this case, maybe this is all you need and you don't need to do anything more complicated. So that's simple delivery. In complex delivery, you can do fan out. So what you do is you connect a source to a channel, like an in-memory channel or Kafka channel or something like that. And then from the channel, you create subscriptions, and then you connect those subscriptions to services. And what this enables you to do is that when you send a message, that message is fanned out to two services, right? So this enables fan out, basically. And then there's also this notion of event replies in Knative. So in this case, for example, we are sending a message, it gets fanned out to two services. And service 2, when it receives a message, it can reply back to that message, and that reply can be routed to other subscriptions and other channels. So in this case, we are routing it back to subscription 2 that goes to another channel, and the channel can have other subscriptions and other services attached to it. So this way, you can do more complicated things where one message triggers two services, and then from service 2, you can trigger other services as well. But one problem in this case is that this is already getting too complicated, right? We have one source and 3 services, and then to connect everything together, we need to create 3 subscriptions and 2 channels, and we need to hook them up together. And I actually show you this. If you go to my tutorial, I show you how to set this up in complex delivery reply. I actually set this, and you can see I create 2 channels, and then I create a source, and then I create 2 services. Then I need to create the subscriptions and connect to those services. Then I need to create the 3rd subscription and the service. So you can see that it's quite complicated to set things up properly. And that's why we have this simpler model called broker and trigger delivery. And in this model, what you do is that you send messages from source to a broker. And broker is something that gets injected into a namespace. You just label your namespace. A broker gets injected into that namespace. And then your services, when they are interested in certain types of messages, all they need to do is they need to create triggers. So in this case, for example, service 1 creates a trigger and filters on this kind of messages. Same with service 2. And then each service can also reply back, just like here, service 2 is replying back. And because we have triggers with filters, only service 3 will receive this 2nd message, right? So when you look at this model and this model, they are the same use case. They're doing exactly the same thing, except in this case, what you need to do is much simpler. You just need to create triggers with the right filters, and everything else is done for you. So that's why I suggest that broker and trigger delivery is a better way of dealing with setting up eventing. All right, so that's Knative Eventing delivery models. And the last thing I want to mention is Knative GCP project. So this is another open source project from Google. It's related to Knative, but it's not part of Knative. Knative GCP, it's basically a repo that contains event sources from Google Cloud. So if you want to read Google Cloud events into Knative, you can install these event sources, and they will pull the Google Cloud events for you. For example, if you want to read Google Cloud PubSub messages, you can install Cloud PubSub source, or you can, if you want to read storage events, you can install Cloud Storage source, so on and so forth. So I mention this because my demo uses these, and they're useful in case you want to read Google Cloud events. All right, so finally, let's bring this all together. So what I want to do here is that I want to show you an app that I wrote over the lockdown, and this was back in March and April, when I told you I'm based in London, and we had a lockdown back in March and April. And during the lockdown, I found myself checking the COVID-19 cases in UK quite often. Every day at 4 p.m., they would publish numbers about COVID cases for the day. So I would go to this website and check the numbers when they're published. And then what I would do is that I would get the data for the day, then I would combine it with the data that I had for the month, then I would create a chart to display the data so I can see how the things are progressing, if the rates are increasing or not, and just look at the chart that way. And I would do the same thing next day. So after like a week or two, I said to myself, I'm doing this every single day, so I might as well just try to automate it, like every software engineer tries to automate things. And then I decided to use Knative because it is like a schedule-driven kind of thing. Like every day at a certain time, I do a certain thing, and there's distinct parts to it, right? I'm reading data, I'm creating a chart, and I'm looking at the chart. So what I did in this case is that I said, okay, let me just create some Knative services to do this for me. So in this processing pipeline, what I have is that first I set up Cloud Scheduler, which is Cloud Scheduler. It's a scheduling service from Google Cloud. It's kind of like cron on Linux, except it runs in the cloud. I set up Cloud Scheduler to send a message to my service, in this case, Query Runner, every day at 4 p.m. with a country data. In this case, the country data will be United Kingdom. And Query Runner will take this data from Cloud Scheduler every day, and it will go and ask BigQuery about some data. BigQuery, it's a data warehousing solution from Google Cloud, where you can read your own data and run queries against that. But the good thing about BigQuery is that it also has public data sets that you can ask things from. Those public data sets, there are data sets about GitHub, about Stack Overflow, things like that. But it also has data sets for COVID cases from different countries. So what I do here is the query runner runs this as BigQuery runs the BigQuery job and gets the data for the country that's being passed in, like United Kingdom. And then once it gets the data, it saves its data into a temporary table in BigQuery. That's what I do here. Then once it saves the data, it sends a custom cloud event back to the broker. So it sends a notification, an event to broker, and it says query completed, meaning I run a query and there's a table ready. Now this message gets read by another service called Chart Creator. Chart Creator, it's a Python service that will receive this message and say, okay, there's new data. It will go to BigQuery and it will read the data and it will generate a chart from the data using matplotlib library or Python. Right? And once it generates the data, this chart, it will save into cloud storage. Cloud storage, it's a object storage service from Google Cloud. So it will save that image there. Then you can set Knative so that whenever a file is saved into a bucket, it can send a cloud event to another service. Now this third service will get this notification from the bucket, and it will use SendGrid, which is an online service, to send emails. So it will get the notification there is a new chart, and it will use SendGrid to send me an email, right? So what will happen is that basically every day, 4 p.m., I will look at the data, I will generate the charts, and I will get an email with that chart, right? That's what this pipeline does. And the beauty of this is that this whole chain is event-driven, right? It's driven by Cloud Scheduler, but all the services, they're connecting via events. They're async. They don't really know about each other. They don't really care about each other. They're totally disconnected. Now, to set this up, let's see if we can actually make this run. First, let me go to Eventing, processing pipelines, BigQuery. By the way, all of this is on GitHub, so if in case you're interested, you can take a look. So first, I need to set my scheduler source. So if you look at the scheduler source UK, you see that I'm using Cloud Scheduler. So I'm using the event source from Google Cloud, and then I'm deploying that to Europe West. And my data is United Kingdom, so the message that this will send will have United Kingdom in its body. The schedule is 16, so it's 4 p.m. every day. It will send a message with United Kingdom in it. And where is it going to send? It's going to send to sync. And this sync is a broker. It's the broker in my namespace, right? So that's what this does. Let me create that, scheduler UK. And then I also want to create an event source for storage events. So if we look at the storage charts, this is using Cloud Storage Source, another event source from Google Cloud. And then it's looking at this bucket that I already created. And then whenever there's a file that's saved into this bucket, it will also send it to the broker, right? So let's create that as well. And then, Then we have three services: the query runner, the chart creator, and notifier. I don't think we have time to go through the code for these, but maybe I'll just show you one of them. So if you look at the query runner, so if we go to eventing and processing pipeline, BigQuery, and then under the query runner, it's C# code. And then if you look at the startup, you will see that it receives a post request, and then it creates a BigQuery client. Then it reads the cloud event. It receives a cloud event. It extracts the country from the cloud event. Then from the country, I create a table ID. then I run the BigQuery, and then once I'm done, I send a reply back. So this is a Cloud event as well, with the dataset ID and table ID. So I'm basically sending a Cloud event with the table ID, so that the next service in the chain knows where to look for the table. So this is the kind of code that you need to write to get things working. So let's look at Query Runner. So the Knative service, it's just Query Runner pointing to the image of the Query Runner. And then if you look at the trigger is filtering on scheduling events. So it only cares about scheduling events, right? And once we see a scheduling event, we send it to Query Runner service, right? So let's create the service and the trigger. Then let's go to chart creator. It also has something similar, the trigger and the service. If you look at the trigger of the chart creator, the only difference is that the chart creator is looking at these messages, the type of Knative samples query completed. This is the custom events I'm sending from Query Runner, and this is what the chart creator gets, right? So that's what I'm filtering here. And then the third one is the send grid one. So if I do kubectl apply, create the service and the trigger, and if you look at the trigger, again, this is only caring about the Google Cloud Storage events coming from the bucket. And actually, let's look at the pods now. Let's look at the pods like this. You can see that I have some pods running already. If I look at Kubernetes Knative services, we have the Knative services. And if you look at triggers, they're ready as well. Now I can wait till 4 p.m. to trigger this event, but I can also trigger the event manually. If I do gcloud scheduler jobs list, I can see that there's already a job that's been there's a job that's been scheduled. Let me actually make sure I'm in the right project. Yes, I'm in the right project. And then I can trigger this job by saying scheduler jobs run and pass in the ID. Now the job is being triggered manually. And we should also see the pods are being created. So you can see some pods are terminated because we haven't used them for 60 seconds, but there is a pod that's been running. So if you look at the Query Runner pod, for example, we'll see that the Query Runner, it received this Cloud event, which is the scheduling event that has the custom data, which has the country code base64 encoded, and then it extracts the country United Kingdom, and then it's running this BigQuery job. And then once it's done, it's replying back with this Cloud event. And then the data is the dataset ID and table ID, right? So it seems like it's working. And then if you look at the other pods, they are also running. You won't have to look at the logs of all services, but if everything is working, I should receive an email. So let me just check my personal email. Yes, I already received it. One sec. So let me move this to the main page. Let's go here. So this is my email, and hopefully you can see this. But basically, I got a new email. It says a new chart is available for you to view, and it points to the storage. And then you can see the chart that's been created as well. And you can see that unfortunately we have more cases coming nowadays, so that's why it's becoming steep in the UK. All right, so I think that's all I have for today. So as I mentioned, if you want to get the slides, it's already on speaker deck. If you want to look at all the demos I want to show, they're on this GitHub page with Knative tutorial. And as I mentioned, if you want to run this on Google, you probably want to use Cloud Run. And I have a separate Cloud Run tutorial for that as well. Thanks for listening. And I will just pause here and see if anyone has any questions. I will also check Slack